In this short video, we're going to change the way that we define an asymptote slightly in the second example. But what we're going to look at are two different types of asymptotes that aren't just horizontal and vertical lines. So here we have a quadratic over a linear function, just x, going with a very simple one. If we were to find the horizontal asymptote, we would find that there isn't one. And we know that there's a vertical asymptote here, but there's actually another asymptote. There's what's called a slant asymptote. If we divide this, we get x plus 2 plus 1 over x. As x goes to infinity, remember that's what we do when we're taking and finding asymptotes, when we want to know what's going on at the outer edges of this graph. If we take the limit as x approaches infinity of f of x, this does end up being infinity, but what happens is this extra term, this last term, this 1 over x, that approaches 0. And so the rest of this is approaching the basic shape of x plus 2. And if we look at our graph, we see this. It's a weird little curve. It's got this diagonal looking asymptote. If I graph one more curve, if I graph the line x plus 2, you can see that that does indeed look like what other asymptotes look like. And this graph has this slant asymptote. Now, these two examples are not part of the IB curriculum, but it's a good thing to know that these sorts of things are out there. And we find these other asymptotes by doing long division or doing just division like I did. We have a cubic over a linear function. If I do my division, x squared plus x plus 2 plus 1 over x, if I take the limit as x goes to infinity of that, what happens? Well, the last term effectively becomes 0. The limit of 1 over x is 0. And the rest is infinity, but it's going and following the path of x squared plus x plus 2. This function has an asymptote that is a parabola, ladies and gentlemen. Asymptotes don't have to be lines. Whoa, mind blown, right? So let's look at what this graph looks like. Woo, look at that fun looking thing. We've got that vertical asymptote at x equals 0. And if I graph that quadratic, x squared plus x plus 2, we can see that, yeah, this curve over here is approaching that curve, and this curve over here is approaching that curve. That's weird, right? I thought asymptotes had to be lines. Well, they don't. And the way we find these weird, peculiar, curvy asymptotes is by doing division. And these things occur when the numerator has a higher degree than the denominator. And that's where I stopped for this section. I hope you had your mind blown just a little bit and thought that that was kind of neat.